Hi, and welcome back to the shop. Today we're looking at, well, jigs and fixtures, and we're up to our part 9 video in that series of videos. And if you recall, in the part 8, well, we just finished squaring up and preparing our block to produce our second jig, which was going to be a vice-held jig to hold the jig vertically, because we're going to be drilling through the tertiary surfaces of our part. Now, up till now, we've been mainly interested in form, squareness, flatness. But now we need some real hard numbers. So let's head over to the whiteboard and calculate what those dimensions that I'm going to need are. So here's what we want to do. We want to pocket out a space for our part to fit into. The depth of that space, that pocket, well, is going to be not quite as deep as the part is thick, so that when I put the part in there, it's going to be just proud of this surface. And that means that when I hold it in the vise will hold the part in the jig. Now, so this pocket is one for accepting the part. I'm going to want about a 3/8 of an inch here, about a 1/4 inch there. Doesn't have to be accurate. And I'm going to drill 1, 2, 3, 4 1/4 inch diameter holes. Just drilled, don't have to be reamed, don't have to be accurate, just 1/4 inch drilled holes, and a 1/2 inch drilled hole in the center here, about in the center. That's really not important. So that's just drilled as well, doesn't need to be reamed. Now, we know that this pocket has to be wider than our part. I'm going to make it 1/8 of an inch wider, just so that it's easy to figure out. And that'll be 1/8 of an inch wider in this direction and in that direction. And that 1/8 of an inch, I'm going to want it to be there and there. These two surfaces I'll leave pretty well at 1/4 and 3/8. And that will give us about a 1/2 inch for these two surfaces here. And that'll do just nicely. And I'm going to do all that without measuring anything. You don't have to kill yourself or go crazy with measurements. Sometimes just geometry is good enough to get to where you want to go. And that's what we'll do. We're also going to be milling to scribe the lines. Why? Because the only thing that has to be accurate here is this surface accurately parallel to this surface, because it's a reference surface, and this surface accurately perpendicular to this surface, because it also is a reference surface. Nothing else here has to be accurate. And we know that our block is already accurately square, so we don't have to worry about that. So really aligning the part to get that pocket with good and square and parallel and perpendicular down here, that's all we have to worry about. So we're going to lay out these 4 lines. We're going to prick, center punch, and drill these 4 holes. We're going to just prick and center punch anywhere towards the middle here and drill that 1/2 inch hole. And then we'll be heading over to the lathe. We'll be heading over to the mill to do the pocketing itself. And when we pocket here, we're just going to be cutting to those scribed lines that I've put onto the part. So let's go do this layout without measuring anything. Okay, so I have my part, and I have blued the surface that I want to lay out on. The first one is a 3/8 of an inch line along this surface, and for that, without having to measure, I'm just going to use this 3/8 tool, lathe tool, high-speed steel. But we have a problem with this style of height gauge. I can't get there. What am I going to do? Well, I'm just going to create another level. There. So now, I could either just go and lay out a line with a scriber, and, well, I'll use this instead here. So, I'll just come down upon it, tighten it in place, remove this, and we can come and lay out our line. Now, the next line is going to be on this surface, and it's a 1/4 inch from the edge of the part. And well, I have a 1/4 inch high-speed steel tool here. So we'll do the same thing. I'll just set up on the top of that tool. There, remove that, and come and lay out our other line. There you go. So we have 2 lines. And next line, well, is going to be on this surface here. And I wanted about a 1/2 inch, but I really wasn't sure. I'm going to have to add something here because I want 100 thou more than the width of the part. So here's my part. Here's my 3/8 from that surface. Here's my part. And well, I wanted 100 thou. So here's a 101 thousandths of an inch drill. I'm just going to add there. I'm going to come over here. And I'm just going to come and touch off that drill. I don't know where I am. I don't have a dimension. I don't need one. I know I'm 100 thou wider than my part. And I'm on that same blank tool, well, high-speed steel tool. So I'll remove all of this. And we'll lay out that 3rd line just over here. There we go. There we go. So we have 3 lines, and we need a 4th line. Again, 100 thou more than the part. So on this surface we used a 1/4 inch tool, so there we go. Here's my part, and I want an extra 100 thousandths of an inch, so I'll just put my drill on there. And, well, away we go. We'll touch off the top here, lock that in place. Remove all of this and lay out our line. Well, there we go. We have our 4 lines. Now what we need to do is punch those holes so that we can drill them, and well, punch one in the center there so that we can drill that one. So now we can prick punch those 4 positions. And one in the center, approximately. There. Now, I can hear people saying, you're laying out on a surface plate. Well, not really. What this is a large chunk of 17.4 pH, condition H900 stainless steel. So this is hard and it is tough. And I use it as basically a layout, a rough layout kind of surface plate that I can be a little rough with and not be worried. So it's really just a huge chunk of stainless steel. So that's our prick punch. Now we can center punch. Okay, that's looking pretty good. There, we have our 4 holes and, well, our hole in the center to knock the part out. So let's go drill these holes. First we're going to spot these 4 holes and well center drill this one a little deeper because the chisel edge on the 1/2 inch drill is going to be quite a bit wider I should say. Now we can drill our 4 1/4 inch holes. let's stop here for a second to clarify something. The first tool that I used, the larger one, well, I pocketed in the z-axis right down to 596 thousandths of an inch. But I want a pocket that has a depth of 600 thousandths of an inch, or 0.6. Now, the second tool, the smaller one that I'm just setting up here, well, I've set at a depth of 604 thousandths of an inch. Why is that? Well, it's quite simple. That first tool we used, we set the depth by touching off the top of the part. And you may not have noticed, but I gouged the part slightly by about 4 thousandths of an inch. That meant that the cutter was already 4 thousandths of an inch below the surface. So I just plunged 596 to get my 600. Now you say, well, you gouged your part. I wasn't being careful, mainly because I knew that that part, or that section of the part, was going to be removed during machining. So leaving a mark there really didn't bother me. However, on the second pocketing operation, the one to just finish up the edges right up to the holes, well, I did it at 604. I'm going to end up at 600 because if you remember, I touched off a piece of shim stock that was 4 thousandths of an inch thick. I used the shim stock because where I'm touching off the part is going to stay right till the end of the project, so I don't want to leave a mark there. So here's the one we made a few weeks back, and we used this one to produce the two holes in the primary surface. The one we're making now is similar, the main difference being that it's much, much deeper. And it's deeper because our part has to be just proud of this surface here, because I want the vise to be able to hold it. And as always, well, we have our foolproof pin here to make certain that we can't put our part in backwards. Now, or any other way than the way it's supposed to. We still have some work to do here. We have a drill bushing to set up, and that's going to have to be very accurately positioned. And, well, we have our two ball spring locating devices that'll push our part against its reference surfaces. So I kind of went out of my way up till now on this project to show that there are two types of accuracy. There's dimensional accuracy and there's geometric accuracy or precision. This, up to this point, did not have to be dimensionally very accurate. And that's why we did not waste our time positioning our holes accurately or doing anything else such as trying to get a specific dimension. We want to be close, but 10 thou on everything here is more than good enough. So that's one thing. And I also stress the fact that if something doesn't need to be accurate, well, you don't have to make it accurate, and if you want to do it just for fun, that's fine. But if you're doing it to produce parts, well, really, as we've done here, close is good enough for most everything here, except for the geometric precision or accuracy of the bottom surface of this jig, the top tertiary surface parallel to that bottom surface, and the secondary surface perpendicular to that bottom. That's all that really mattered here. And well, we have it. So, that's enough for today. Until we meet again, well, have fun, but be safe and happy machining.